Let's do a problem from your lab assignment, section 8.4. This is problem number 2. The marginal cost is defined by c prime of x, and that was a derivative of the original cost function. If the marginal cost of manufacturing x meters of fabric is given by this is c prime is equal to 3 minus 0.004x plus 0.000006x squared measured in dollars per meter, then the fixed startup cost is c is equal to 0 is equal to 15,000. Use the net change theorem to find the cost of producing the first 1,000 units. So the net change theorem is essentially the second fundamental theorem of calculus, which tells us that the integral from a to b of the derivative of something is equal to the original function evaluated at the endpoints. We kind of saw it as a function and the antiderivative, but since this is the function that we're dealing with, we want the derivative of the function inside of the integrand. So this is the statement in the fundamental theorem of calculus that says the integral of a derivative is the original function evaluated at the endpoints. So that's your net change theorem. So now that we have that, we're going to find the value of certain things. So C of 1,000 is going to be, the C would go in this slot, C sub 0 would go in this slot. Bring it over to the other side, so that C of 1,000 is equal to that plus the integral. Now C of 0 is actually 15,000, so we can just punch that in, and then we'll evaluate the integral in our next step. So the antiderivative of this thing is going to be, the first term is going to be 3x, and then we have this thing x to the, oops, there's an x out here already, so let's take that x out. It's going to be minus this thing x squared divided by 2, so we want 0.004 divided by 2, which is 0.002. And then now we have this thing, this constant, and then the antiderivative of x squared is x cubed over 3, and it looks like they divided this this big decimal by 3. They divided it by 3, so we don't need to worry about that. We just need to worry about the power of x. Alright, it looks like we need to compute this by putting in 1,000. If we put 0 in, this thing is going to be 0, 0, and 0, so the whole parentheses will be 0. So we won't have to worry about that. So we just need to worry about this thing when it's equal to 1,000. So we got 15,000 plus, and then let's put the brackets here and let's work this stuff out. So 3 times 1,000 is 3,000 minus, this is going to be 2, or 1,000 squared, so 1, 2, 3, 4, 5, 6 zeros, and that would move the decimal 1, 2, that's 1, 2, 3, 1, 2, 3, that's 2, 4, 5, 6, so it's 2,000, and then we have to the third power. Okay, this is counting a lot of decimals, so I'm just gonna pause for a moment and see if I can just figure that out using a calculator. Okay, I dug out Wolfram Alpha and I plugged in these values. I got 15 plus 3 times 1,000 minus 0.002 times 1,000 squared, and then I hope I got the right amount of zeros here, times 1,000 cubed, and it looks like my answer is going to be 18,000. So let me go ahead and get rid of all this and put 18,000 there. All right. Okay, so I think that's it for that. Hope that helps.